because we've used the derivative and we have found these zeros of the derivative, easy enough to find, we go over here and we can match up, and sure enough it's going to be there. Now the question is, what are the intervals of negative derivatives and positive derivatives? Well, again, if I look for a derivative between -1 and 0, it should be positive in value. Okay? And if I look for one between 0 and 1, it should be negative. And then over here would be negative and positive. So what we can do, and I can't remember now how your book presents this, so I'm going to give it to you in the way that I have in my notes, even though we've got the Inspire that could really help us out a lot. We're going to set up a table, and we're going to look at intervals. We're going to look at test values. It's a sign chart. I'll just put that up here. Sign table, sign chart. I don't know what name the book's using, but we'll call it that right now. We're going to look at the sign of the first derivative, and then we're going to have a line here for conclusion. Okay. So I've got now this, I've got on a continuum here, if I were to, let's pretend this is my number line, I could put down that, let's say this is -1, this is 0, and this is 1 over here. I've got my number line now divided up into 1, 2, 3, 4 intervals. I'm going to go from -infinity to -1. From -1 to 0, 0 to 1, and 1 to infinity. These are, you might want to make that note. Are these inputs or outputs? The interval. Are we inputs? You might want to put that in if you're not sure. These are input values here. Okay. I'm going to test a value in this interval. I can choose anything. Is it true that any input value less than -1 would have the same sign on the derivative? Doesn't have to be a special one. Anything I want. Any input value between -1 and 0 is going to have the same value or the same sign of the derivative. It should be positive, and so forth and so on. So all you have to do is just choose anything. So we can choose an x equaling -2, an x equaling -1/2, x equaling 1/2, and let's just say x equaling 2. We're just going to test out a get a test value, one for each of those intervals. What's the sign of our derivative going to be in each of those? Well, what I'm asking for is, if I put -2 into my derivative, let's see, where's my derivative? Negative 4x cubed minus 4x. If I put -2 in that, is my derivative going to be positive or negative? That's all I want to know. I don't need a specific answer. I just need to know, is it positive or is it negative? I could also put it in my factors here. So let's see, I like my factors better because if I put a negative, like a 4 times -2, and then a -2 squared minus 1, is my first factor going to be positive or negative? 4 times -2. Negative. -2 squared minus 1. Positive or negative? -2 squared. Positive minus 1. What's the sign of that? Now I need to get, let me do that for you and then you come back later? Okay, we'll do it. What's the sign of a negative times a positive? It's a negative. So the first derivative is negative, my conclusion is that f of x is what, increasing or decreasing? Decreasing. The first derivative is negative, so the function is decreasing. Is that what we said over here? Decreasing? Yeah, exactly what we said. So I'm going to go up here now, and I'm going to use, there are my factors. I'm going to use the factors again with negative 1/2. So 4 times negative 1/2 is, 4 times negative 1/2, positive or negative? Negative. Negative 1/2 squared minus 1. Negative. Are you pleased? A negative times a negative is positive. Is that what we see over here? Yes. Okay, so we can choose any value we want. Now, I have to tell you, some of this work, like the sign chart, was extremely important to people like me when I was sitting in a place like you are. We had no calculator. We could not see a picture of this unless we did lots of points and then try to connect the dots in a reasonable manner. We couldn't just put it on a calculator and see a picture. And so it was really important that we had other ways of doing it. So the sign charts, a lot of good mathematics here, but the sign charts were extremely necessary to us. Are they as necessary to you? When you look at this, can you tell me where those are? You take the derivatives, can you look at this and see this is going to be negative and this is going to be positive? Yeah. So, a question that we now have is, how much of this do I really hold you to? Well, I hold you to knowing the idea that if you have a positive and a negative, it's a negative and so forth. I hold you to the idea that you need to factor this out in order to find these, I'm going to call them this already. They're called critical numbers. That's going to come up later on, but these are critical numbers. X equals 0, x equals 1, and x equaling negative 1. Those are called critical numbers. So if I continue on, by the way, if the first derivative is positive, what do you know about the function? Increasing, right? Second derivative, or the next one, if I put 1/2 in there, 4 times 1/2 is positive. 1/2 squared minus 1, negative. Are we surprised that it's negative? No. Is the function increasing or decreasing? Decreasing. Do we see that on the graph? Yeah, all this stuff follows the graph. So if you do a combination of this, you should not have any trouble with it. Let's do one more just to make sure the notes are complete. If I put 2 in, my test value 2, 4 times 2 is positive. 2 squared minus 1, positive. Is the function increasing? Yes. Okay, so the analytical work, and again, I show this to you because I can't remember what the problems on homework look like, but I want you to have this. I want you to know how that sign chart looks. They may have you do sign charts on some of those problems, so this is what we're talking about. Okay, always connecting it with what what we see on the graph. Okay. Here we go. I knew it was coming up. I've done this lecture for the Calc 1 class. Is almost identical to this, but the way we say things in each class is a little different. So here's where you get the word critical number. Now I know the tendency is to want to write every single word down because you think the words are that important. They're not. It's the thought process we're going through. Critical number. Just remember that it's critical number. The function is defined at, is C an input or output? If f is defined at C, value C, input or output? Input, yes, an input. So if the function is defined at that input value C, then C is a critical number. There we go, critical number of the function if the first derivative is 0, and this is very important, if the first derivative is 0 or if it's undefined. Okay, if the first derivative turns out to be undefined, where it's undefined is also called a critical number. I don't know if you've seen many of those in the other class. We've seen them, but I don't know if we've seen very many undefined functions that have undefined derivatives. Okay. Guidelines.
So you're saying it's still a critical number?
Yes. Yes, it is a critical number. Now, let me just share with you that one of the ones, and I can't remember if we did that in this class or not, but if we have a function like this, we know that the absolute value function, we could see it, I guess. This value c, the derivative is undefined at that value c. The reason is, what's the sign of the slope of this portion? Negative. Okay, so the derivative as we approach c from this direction, the limit is negative. What is it on this one? Positive. You know, if you try to clap, you can't. Okay, so we say that the derivative is undefined because the limit does not exist at that point. And that's one of the reasons, one of the ways that the derivative is undefined. Okay, guidelines for applying. I want you to put all your pencils down. I don't want you to do this. If you want to know these notes, you can go back and find it, but this is too much writing for you to focus on that. Let's just listen for what we're doing here. Find the derivative. Did we do that? Yeah, okay. Locate the critical numbers and use those numbers to determine the test intervals. Did we find critical numbers? How did we do that? I'll put it on here. Set the first derivative equal to 0. That's how we find and locate the critical numbers. Okay. Test the sign of the derivative at an arbitrary number in each of the test intervals. Did we do that? Back here. Remember I said use a test value. Anything that's in this interval, use it because it's true for all numbers in an interval. Okay, so we did a test value. And then use the test for increasing and decreasing functions to decide if the function is increasing and we did that. Okay? So all these words, you did it. Look at it later. It's in the textbook, but I don't want you to think. I don't want you to write that down. Okay. Let's apply it. Find the critical numbers. Step 1. Take the derivative. What rule do we have to use? We're going to use that, but the first one we're going to use is, I heard it, product rule. Yeah, we have to. You got the product of x times the cube root. Now the first thing, actually the first thing I would do. Yeah, I'll stop that in just a minute here. First thing I'm going to do, instead of taking the derivative, I'm going to rewrite this as x times x minus 1 to the 1/3 power. I'm going to rewrite it that way because I know I'm going to have to use the 1/3 power. That's a cube root in case you couldn't see it back there. Okay, now I'm going to take the derivative and I am going to use the product rule. If you're not familiar with that, you need to be. So it is the first factor times the derivative with respect to x of the second factor plus the second factor times the derivative with respect to x of the first factor. So keep working. Okay, just a little reminder, yes, this is the product rule. And then I think it was Aaron, you mentioned we needed to use the chain rule because inside this derivative we've got a composite function. So let's see, we've got x and then we've got something to the 1/3 power, so it's 1/3 that something to the negative 2/3 power. Then the derivative with respect to x of x minus 1. And the derivative of x with respect to itself is just 1. So let's see, I've got x divided by 3 x minus 1 to the 2/3 power times 1, the derivative of x minus 1, plus x minus 1 to the 1/3 power. I've taken the derivative. We're trying to find what? Critical numbers. Critical numbers are where what happens? Slope is 0, or slope being first derivative, we know. If first derivative is 0, or first derivative is undefined. Okay, so the second thing is, let's do the setting it equal to 0. So I have 0 equals x divided by this. Now we can convert any time back to the cube root if you like. Okay, anytime you want to, we can do that. I see a couple of things we can do. Give me one suggestion. Katie, what are you thinking? If your life depended on it, how would you solve for x? I think Phil's going to help you with something.
Well, this is a guess, but like multiply both sides by the denominator on both sides. So like multiply both sides by 3x.
Okay, so if I multiply both sides by that, this side's going to stay 0. If I multiply this side by x minus 1 to the 2/3, you said?
Yeah, both sides. So the denominator cancels for
But over here, what am I going to end up with? Multiply both sides, I'm going to have to multiply this one also?
that.
Yeah. It's a good start. It's a good start. Okay, keep thinking about it.
Maybe distribute the 1/3.
But it's to the 2/3 power. What's the order of operations say?
Other,
So do what now? You mean to tell me you were going to tell me you wanted me to do something like take the cube root of, I'll make it the square root of 9 minus, whoops, I don't want to do that.
I don't know.
25 minus 9, and you wanted me to say that that's the square root of 25 minus the square root of 9, something like that? Want to do it with cube roots instead? Would it work? This is, I think, the square root of 16, right? Which is the same thing as 4. This is 5 minus 3. Well, you tell me. Is it going to work? The answer is no. Okay, I'll take that answer. Okay. You cannot distribute when you're dealing with an exponent. Okay. Some other good suggestions. Maybe I write one now. No. Good suggestions are good, whether they're right or wrong. Okay, so what do you think? Aaron? Yeah, you got a choice there. Go ahead. Aaron Austin. While she's doing that, Stephanie, would you close that blind? I got a glare of a car. Yeah, that one right there. Glare of a car. Don't we love the sun? Okay, go ahead, Aaron. Thank you. Okay. Well, I don't know what you're going to do, but let me just kind of play around with this a little bit. Anything illegal with that? No? If I do that, what can I do next? Okay, so now I'm kind of getting back to what Phil said, aren't I?
Yeah.
Except that I'm multiplying everything by it. Okay, but it's basically the idea. Okay, so now I've got x minus 1, I got x minus 1 to the 2/3 power, so I think I've got negative 3 times x minus 1 to what power? 1 is 3/3. 3/3 plus 2/3 is 5/3. Is that going to help me any? Where am I going on this problem? What do you think?
72.
You know what? Yeah, I mean, we're going to make it there, but let me give you, I just saw my notes, I saw, this would make it a whole lot easier. What if, and no one gave me the suggestion, but what if we write this as one fraction? Would that make it easier? Stephanie, just gotta speak up faster. You're nodding your head, right? You thought about that? Yeah, give yourself credit. Okay, so Stephanie's going to help me now. She's back there. She sees it already. So Stephanie, take it. Okay. So it's, again, back to what Phil was saying, more or less, kind of.
So you multiply the x plus 1 and 1/3 by the nearest fraction.
And place it all over. Okay. So I don't like this piece. Not that we couldn't finish it up. If you've got it on your paper, keep it there. You can do that. It's just not where I want to go with this today. Okay, so now I've got this. I've got 0 equals x plus 3, the quantity x, minus 1. There, here we go again. Well, except it's just that, isn't it? Divided by. Phil, were you getting this?
What's that?
Did you get this? You were telling us how to, we were going to kind of use your idea, and then I
was turning to it.
know, and then I told you no, didn't I? That's my fault. Okay. I take the blame. Okay, let's see here. Okay. So now what? And is this right? Okay, so now what? Our numerator is now, I got 4x minus 3. How about you guys? Okay. So now that you've got a fraction whose value is 0, now what do you know? Say it again. Don't check your arithmetic out the door. If you got a fraction whose value is 0, which part of the fraction is the only part that can give you a 0 value? The numerator. Now, if you didn't think about that, well, maybe you thought about multiplying both sides by this. Okay, that would still give us that 0 equals 4x minus 3. You like this? It's getting easier? Looking good? X equals what? 3/4 or 4/3? 3/4. Okay. Whew. So what? What do I have? What does this tell me? Yes, go back. We're trying to find critical numbers. What good are critical numbers? I use CN for critical number. You may use it also. I don't know what that means. It's a critical number. Therefore, what? We know that the slope of the tangent line at that point is 0. Okay. What else do we know?
It's either increasing or decreasing.
On either side? Okay, so now we need to go search for, is it increasing or decreasing on the left side, the less than side? Well, here we go. Here's my 3/4. That's on a number line. Okay, so I've got my, my intervals I have to talk about. If I'm going to divide my number line split it at 3/4, I have an interval of negative infinity to 3/4. And the other one is 3/4 to infinity. Okay. I need a test value. Is that an input or output value? Input. Okay, let me make sure. Did I skip a step here? Nope, test value. Next thing we did. Okay, so a test value. What are you going to test? Give me an easy, it's late in the day. Give me an easy value to test. Oh, give me something easier. 0. I like that. Wouldn't 0 be easy to test? Where's my derivative? Where'd we end up? Right here? My derivative. If I put 0 in there, I can really tell you what that's going to equal. So that's easy enough. Okay, what's another test value that would be easy to do? 1. Okay, don't have to be very far away from that value. Okay, so now what's the next step? Sign of what? Derivative or the function? Derivative. Okay, so if I go back up to my derivative and I put 0 in here, I have negative 1 cubed, and then I square it. Negative 1 squared is how much? It's positive, right? Cube root of that is, but I'm going to put 0 up here, so what does it matter? Right? This thing is 0, as far as I'm concerned. I'll put 0 in for x. You with me? Okay. Over here then, 0 minus 1 is negative 1. Negative 1, the cube root of negative 1 is negative. I only need to know what that's negative. So the first derivative is negative. What's my conclusion? F of x is decreasing. Okay, now I've got to put in 1. Go back up to your function. 1 minus 1. Uh-oh. Can I use 1? Did we test that out? We only tested to see if the derivative was 0. What else happens at critical numbers? Undefined. If I put 1 into this derivative, what happens?
Undefined.
Undefined. I can't do that. So I'm going to have to alter this a little bit. And instead of saying from 3/4 to infinity, I better make it to 1. And I better not use 1 over here because that makes it undefined. I better make it instead, oh, I don't know. What should we make that? 9/10 or something like that? 7/8, whatever you want it to do. And we're going to have to say 1 to infinity. Now, in order to make sure we get through this problem, I'm going to just say, let's go to our graph. Thank you. Nice. Okay, we'll let it record. Let's see here. What kind of a window? It looks like, let me try negative 1 to, we don't need very much, I don't think. Let's try 5 to start with. Scale by 1. And it didn't look like it went below the input axis, hence the square root there. So we'll say negative 1 and 5. Okay, not too bad, not too shabby. Now, we had negative 3/4. So negative 3/4 is, well, let's put a point on it and make it, find out where that point is. So I'm going to put a point on it. And I don't want negative 3/4, I just want 3/4. So 0.75. Oh, yeah. Why did that line come? Because I moved it close to that, and it thinks that it's a line. Yeah, I know you don't like that. Let me try that again. Okay, so there it is. If you take that point and move it too close to a horizontal line, it makes it into a horizontal line. Have you found that happening at times? If it happens, that's why it is. Okay, so there's my point. We also need a point where? At 1. Let's see if we can get a point at 1. Okay, there's the point at 1. I'm going to change the window a little bit more so that we don't have quite, I can maybe see a little more distinction in there. Okay, so there we go. There's our point. Now this is another, we found that the derivative was undefined at 1. And the reason it's undefined is, do you see that kind of vertical portion of the graph? That vertical portion of the graph is indicating that if we were to take, well, let's just do this. This is what we can do. So we'll put a tangent right there. Let's see if I can get a tangent. There we go. There we go. Whoops, didn't make it. Oh, you guys getting points on those better than I am? Let me try that again. I'm going to move. I'm going to try to fool my Inspire into doing something. And it's really not wanting to do it. There we go. Okay. What did I have that at? 2 or 3? Do you remember what I had the maximum at? We'll put it at 2. Okay. What I'm wanting to do, I'm going to put the tangents on first, then move that point down, because I think that's my problem with trying to get that tangent on there. So there's the tangent. And yeah, it doesn't like that point down there. Is anyone able to get that point to move? Okay. The reason I think it's having problems is because of the nature of that. Or not. Well, I'll make the point later, I guess. What I'm trying to do is put a tangent at this other point. Is anyone else doing that, or is it just me? Just me? Thank you. Yeah, I can't either. Okay, well, I'm not going to worry about it too much now. I'm going to change this now again to just 1, and the tangent seems to disappear at that point. And that's why I couldn't get it on before, is because it just isn't going to be there. It's undefined. It's not possible to do that. If I look at the slope of the measure of that, slope of that line, let's see what happens as I bring that point down. There we go. And all of a sudden it seems to disappear at that point. It's getting larger and larger, and it's becoming vertical is what really is happening. And then we can kind of pick it up again. Interesting function. Okay, well, increasing and decreasing, what do derivatives have to do with that? Go back to the so what. Derivatives relate to increasing and decreasing portions of the graph by their Yes, Aaron, help me out. Don't lose it, okay? Don't lose the fact that that is exactly at the derivative sign. It tells us that. Okay, what I want to do is, I'll take a clean sheet of paper, or not a clean sheet, but on the back of your notes, whatever it is that you're working on. And trying to see what I did with that.